All right, here's our last video in section 4.7. We're going to do examples 7 and 8, and we're going to talk about multiplying polynomials with different variables in them. Remember, when we multiply, we really add the exponents, but we can only combine bases that are the same. What I mean by that, remember, if I have an x cubed times an x squared, because they have the same bases, I should be able to combine them and say that I really have x to the fifth. Now, if there were y's next to them, let's say this was an x cubed y and an x squared y squared. Well, I can combine the x's and say x to the fifth, and then I can combine the y's and really say that I have y to the third. I can combine like bases by adding their exponents. Let me show you some examples here. In example number 7, we're taking this trinomial and we're multiplying it to this binomial. We have 3 terms times 2 terms. So we're simply going to distribute all the terms in the first polynomial to all the terms in the second polynomial. So here we go. If I take the 3x squared y and multiply it to the xy, I end up getting a 3x cubed y squared. Remember, I'm combining like bases by adding their exponents. I'm also going to take the 3x squared y and multiply it to the 2y. 3 times 2 is 6, x squared, and then I have a y times a y, which is a y squared. So I end up with a 6x squared y squared. I'm going to distribute now the negative 2xy through. 2xy, negative 2xy I should say, times an xy is really a negative 2x squared y squared. I'm going to distribute it to the 2y now. Negative 2 times 2 is negative 4. I have an x, and I have a y times y, or a y squared. So I have a negative 4xy squared. I'm now going to distribute the 3y to both terms in the second parenthesis. 3y times xy is really a 3xy squared. A 3y times 2y is really a 6y. No, a 3y times a 2y is a 6y squared. I got that right. Sorry about that. All right, now you notice that I put the x first, then the y. That way I can kind of keep it consistent, kind of in alphabetical order, so it's easier for me to see which terms are like terms and see if I can combine anything more. I don't have any x cubed y squareds besides this first one, so I'm going to keep that. But I do notice that I have an x squared and a y squared in the 6 and the negative 2, so I should be able to combine those. Those are like terms. And I have an xy squared here and an xy squared here. So negative 4xy squared plus 3xy squared is really a negative 1xy squared. And then I have the lonely 6y squared. So my final answer looks like this. No other like terms because my exponents and variables don't exactly match. So this would just be my final answer. Let's do a few more different types of multiplication problems with different variables. Look at example number 8. We're still multiplying these two polynomials. We have a binomial times a binomial, which means I'm either going to FOIL or distribute, or you could even do the box method that we've talked about in the past. I'm going to distribute the p through, and I'm going to distribute the 5w through. This is what I got. P times 2p is 2p squared. P times negative 3w is a negative 3pw. 5w times 2p is a 10pw. And 5w times negative 3w is a negative 15w squared. I try to stay consistent in alphabetical order so I can see that I have like terms. I have a negative 3pw and a 10pw. They have the same exact variable with the same exact exponents, so I can combine those and say that my final answer is 2p squared plus 7pw minus 15w squared. All right, look at B with me. Be careful. Remember, there's a plus or minus sign separating my terms, so I can't distribute the squared through. What that really means is that I have a 3x plus 2y times a whole nother 3x plus 2y. We have to make sure that we write it out twice and then FOIL or distribute. So 3x times 3x is 9x squared. 3x times 2y is 6xy. If I distribute the 2y through, 2y times 3x is 6xy, and 2y times 2y is 4y squared. I have like terms in the middle that I can combine, and so my final answer would be 9x squared plus 12xy plus 4y squared. No other like terms, so that would be my final answer there. All right, look at C. Gets a little more complicated. I have a polynomial on the inside. It is squared, but remember there's a plus or minus sign separating my terms, so I can't distribute the squared. I have to actually write it out twice and distribute or FOIL. Remember, when we multiply, we really add the exponents. So here we go. If I have an a cubed times an a cubed, don't I really get an a to the sixth? If I have an a cubed times a negative 7a squared b, I really end up with a negative 7a to the fifth b. I'm going to distribute the negative 7a squared b through. That gives me a negative 7a to the fifth b. And a negative 7 times a negative 7 is a positive 49. A squared and a squared is a to the fourth, and b times b is b squared. I'm now going to combine all of my like terms. It looks like here I have a negative 7a to the fifth b and a negative 7a to the fifth b. Those are like terms that I can combine. I end up with a final answer of a to the sixth minus 14a to the fifth b plus 49a to the fourth b squared. No like terms left. That would just be my final answer. All right, why don't you try D, E, and F? Lots of different things going on, so please slow down. Please be careful with your exponents and combine only the ones that are like terms. Why don't you try these three and see if you got the same thing I did? All right, on D, I'm going to FOIL or distribute. It looks like those are conjugates, aren't they? They have opposite signs on the inside, but the terms are exactly the same. So my middle terms canceled. Hopefully yours did too. And you ended up with the same final answer as me. 9x to the fourth y squared minus 4y squared. They don't have the same exact variables with the same exact exponents, so those aren't like terms. That would just be my final answer. All right, look at E. I'm going to FOIL or distribute. If you notice, they have the same exact term, but one is positive and one is negative. If you were to rewrite those in a different order, those would also be conjugates. So it looks like, again, my middle terms cancel. I ended up with a negative 4x to the 6 y to the fourth and a positive 25t squared. You can write that in any order as long as you make sure that your 25 is positive and your 4 stays negative. All right, did you do F? It looks like F is a little bit different because now I have 3 terms in each. So I've got to do a little bit more distributing. I'm going to distribute the 2x to everything in the second set, the 3 to everything in the second parentheses, and the negative 2y to everything in the second parentheses. Woo, I ended up getting a whole bunch of different terms. Maybe pause the video and see if you got the same terms I did. I noticed that I had a couple of terms that were opposites and canceled each other out, like the 4xy and the negative 4xy, or the positive 6y and the negative 6y. I'm going to then combine all my leftover like terms. I ended up with a 4x squared, a 12x, a plus 9, and a negative 4y squared. Again, you can take these 4 terms and put them in any order, as long as you make sure that your signs stay the same and your variables and exponents exactly match mine. All right, we've done a whole bunch of things with polynomials now with different variables. I would like you to pause the video. I would like you to try these 3. One of them is practicing evaluating. The second one is adding and subtracting. And the last one is multiplying. Pause the video, try these before moving on to your homework, and then make sure you have the same answer, the correct answer, before moving on. And let me know if you don't, if you have any questions still. All right, for number 1, evaluating. Anytime I see an x, I'm going to plug in a 5. Anytime I see a y, I'm going to plug in a negative 2. And then I'm going to make sure that I follow the correct order of operations. I have a 25 minus 2 times 4 minus a 30, which is really a 25 minus an 8 minus a 30. When I combine my like terms, I ended up getting negative 13. Hopefully you did too. Also, hopefully you're practicing showing me all of your work. I want to be able to see that you're plugging in. I want to see your steps of following your correct order of operations, and then I want to see what your final answer is. All right, look at number 2. Number 2 has us subtracting. We're going to distribute the 1 in front. We're going to distribute the negative 1 in front here, and then we're going to combine like terms. After distributing to get rid of the parentheses, my signs in the second parentheses change, and then I'm going to combine like terms. I ended up with a final answer of 5r cubed plus 4rs minus 6r squared. Hopefully you got the same thing as I did. All right, number 3 looks a little bit different. Number 3 has my parentheses right next to each other, which means I'm multiplying now, a little bit different than adding or subtracting. I'm going to distribute the 5x to every term in the second parentheses and the y to every term in the second parentheses. Remember, when we multiply, we really add the exponents. I ended up getting 10x squared minus 15xy plus 2xy minus 3y squared. It looks like I have a couple of like terms. The middle terms there are the like terms. And so I can combine those and say that my final answer is 10x squared minus 13xy minus 3y squared. Hopefully you've got down the evaluation, the adding and subtracting, and the multiplying of polynomials with single variables or with lots of different variables. Make sure that you get good at that because we're going to add to it here in the next section.